Hi you guys, as promised, here we are doing some review for the test, which is going to start Tuesday and finish on Wednesday. I do want to point out a couple of problems on Worksheet 8, just because it's been a long time since we've done Worksheet 8, and if you had questions on it or didn't get to it by the time we went over it in class, there are a couple of things that you're going to have to do on the quiz, or on the test I mean, that come from Worksheet 8, that I wanted to point out before I move to Worksheet 11 and 12 and do a couple of those problems. So go to Worksheet 8 first. Here we are, Worksheet 8. It's the beginning of the packet almost. And I want to start looking at number 5. So number 5, I know that a lot of us were confused when we were going over the quiz on problems that look like number 5. So here we are given 3 different ordered pairs, and we have to do some stuff to it according to what is being done to f of x here. And so what we're going to do first for number 5, for letter A, make sure I can see all 3 ordered pairs. When the number is on the inside with the x, remember what that means is to multiply, whoops, spelled that wrong, x by, you use the reciprocal. So this actually means you're doubling all of the x values. And so what we're going to do here is we're going to take all of our x values, so the 4, the negative 2, the negative 10, and we're going to multiply all of them by 2. We're going to double them. So that becomes 8, negative 3. The next ordered pair becomes negative 4, comma 0. And the last ordered pair becomes negative 20, comma negative 15. So the y value stays the same, but the x value gets doubled. Okay, now opposite of that is that what happens if there's a 3 in front of the f of x? Well, I like to remember that the f of x is just a fancy y. And so when you do that, what you do is multiply the y's, not by the reciprocal, but by that number exactly. So you multiply the y values by 3. So up here we're taking all of these y values, the negative 3, the 0, the negative 15, and we are tripling them, multiplying them all by 3. In this case, the x values stay the same. So 4, comma negative 9, negative 2, comma 0 times 3 is still 0, so that one didn't change. And then negative 10, comma, when I take negative 15 and multiply it by 3, I get negative 45. Okay, then the last one's a little bit harder. What we have is here a number with the x. That means multiply the x by 1/2. Always use the reciprocal when it's inside there. In this part, the negative 1/3 means multiply the y by exactly what is there, negative 1/3. Okay, so we're doing something to the x and to the y here. So all my x values are going to change. All my x values are getting cut in half. So that's going to be 2, negative 1, negative 5. And now I'm going to do all the y values. The y values I'm multiplying by negative 1/3. So negative 1/3 of 3 is positive 1. Negative 1/3 of 0 is still 0. Negative 1/3 of negative 15 is positive 5. So that was problem number 1 I wanted to look at for Worksheet 8. There are just a couple others on Worksheet 8 that I wanted to look at. How about this one, number 14? This seemed to trip a lot of us up on the quiz when it was a cube root. Some of you only had the sprinklers. Notice that the cube root is very different than the sprinkler function, which is just a normal square root. And a lot of you are confused on how to make the t-chart here. And some of you I know are noticing that there are patterns that you can follow, and that's awesome if you know the patterns, but some of you are still getting confused with the patterns, therefore I always recommend the t-chart. So if I start my t-chart here, remember you're always supposed to start the t-chart in the middle right with the shift here. The shift here means left 3 and down 1. So negative 3, negative 1 is what I'm going to put right in the middle of my t-chart. That will, if you center that, get you the perfect, like, centered, beautiful graph every single time. Now I'm going to pick points on the left, negative 4, negative 5, and on the right, negative 2, negative 1. This is how you center your graph and make sure that you get both halves of the, like, snake shape, which is what this cube root graph is going to look like. When I plug in, I'll start with negative 4. When I plug in negative 4 here, I get the cube root of negative 1, which is negative 1. Minus 1 is negative 2. When I do the negative 2, plug that in here, and I get 1 minus 1, which is 0. Now if I do my next point, here's where it gets a little bit harder. If I plug in negative 5 here, I can't cube root negative 2. So that's actually not a good number to plug in. So maybe what I should do is choose a different number. And this is the same thing with negative 1. When I plug negative 1 in here, I get positive 2, and I can't cube root positive 2. So I'm going to try and pick better numbers. And here's where you're going to need to do some thinking. What plus 3 gives you 8? Because you know that you can cube root 8 very evenly. So that can be 5. if I plug in 5, that means it's the cube root of 8, which is 2, minus 1 is 1. And then I have to think of a negative number. Something plus 3 gives me negative 8. I think that's negative 11. Negative 11 plus 3 is negative 8, and I can cube root that number. So that gives me the cube root of negative 2, or the cube root of negative 8 is negative 2, minus 1 is negative 3. So now I have 5 beautiful points, and I put negative 3, negative 1 right in the middle. I'm going to continue negative 4, negative 2, negative 2, 0. And the reason why you need 5 points is because if I connected just these 3 right now, this makes just a straight line, and that is not the snake shape that we're looking for. So negative 11, 4, 5, 6, 7, 8, 9 is way over here. It's a little bit off, but that's okay. It'll still help you verify that you have the right shape. And then 5, 1 is right here. So here is our snake, and it's both halves. And that is how you do the T-chart for that one. So always, you guys, starting the T-chart or putting your first point wherever the shift is. Left 3, down 1, right here. Center of the graph. It might be a vertex if it's a V or a parabola. It might be the head of the sprinkler. In this case, it's the center of our snake. All right, I think there was one more on this worksheet. This graph here. We did this in class together, but this was a while ago, and this was probably the most commonly missed part on the quiz that you guys just took. So that's why I wanted to review this one, is that you're given a graph here which has 1, 2, 3, 4, 5, 6, 7 ordered pairs on it, and then you're asked to do some stuff to it. And a lot of you like graphed random lines and stuff and didn't know what you were doing on the quiz here, so we obviously need to talk about this. First of all, this right here is telling you to move this graph to the left 3 and down 1. So that's all 7 of these ordered pairs I need to count and move left 3 and down 1, and that's it. A lot of you try to make that way too hard. So at this point, if I'm starting at negative 6, 0, and I move it left 3, it goes to negative 9, and then down 1 is right here. So I'm doing each of those ordered pairs individually. Now if I do this point, this ordered pair is negative 4, 6. If I move it left 3, it goes to negative 7, and down 1, it goes to positive 5. Negative 7, 5 is right here. And then I'm just going to continue connecting them as I move my way through. So now I'm at this point. If I go left 3, 1, 2, 3, and down 1, that's here. So that's negative 5, negative 1. Negative 5, negative 1. Here we go. So each ordered pair individually. Now let's do this one. I'm moving it left 3, so 1, 2, 3, down 1. So I end up right here. Negative 3, negative 3. Put a point there. Negative 3, negative 3. Now I've got, let's see, this point. I'm going to move it left 3, 1, 2, 3, down 1. I end up at negative 1, negative 1, which is right here. And you can see that the shape is the exact same here. I'm just filtering my ordered pairs as I go through. This one, move it left 3, 1, 2, 3, down 1. It ends up at 1, 3. So I'm going to put a point at 1, 3. And then last one, this one, left 3, 1, 2, 3, and down 1, it becomes 3, negative 1. So I'm going to put a point there, 3, negative 1. So basically what I have done is I have moved every single one of those points left 3 and down 1. So then number 20 is a little bit different. Number 20, what you guys have to recognize is this 2 on the inside with the x. What that does is it cuts your x values in half. Multiply x by 1/2. Okay, just like these ones that we just did up here, boom. This stuff, it's the same exact thing that we're doing now, except here you're given ordered pairs. And also for this graph, you're also given ordered pairs, you guys. You just got to move them yourself. And in this case, we are multiplying all of the x values by 1/2. So it's the same thing. I'm taking these 7 points and just cutting the x value in half. What that's going to do is shrink your graph along the x-axis. So this ordered pair right here is negative 6, 0. If I cut the x value in half, I'm at negative 3, 0, which is right here. The y value stays the same because we don't have a number in front of the f here, so we're leaving all the y values the same. Heads up, in this one down here, you're not doing anything to the x's, but you're multiplying the y values by 1/2, exactly that number right there. So let's continue. We've got this point now. negative 4 comma 6. If I cut the x value in half, it becomes negative 2 comma 6. Y value stays the same. This point, negative 2 becomes negative 1 comma 0. And you can see, like, look how skinny this thing is. It's being pinched along the x-axis. This x value is 0, so if you cut it in half, it's still 0. The y value is still negative 2, so that point didn't change. This ordered pair is 2, it becomes 1 comma 0. This ordered pair is 4, it becomes 2. Y value is still 4. 2 comma 4 is right here. And last one is 6. When I shrink that one or cut it in half, it becomes 3 comma 0. So the y value stays the same, the x value changes. And connect. And that's it. So that is, this graph is this shrunk the x value. It's like pinching along the x-axis. Alright guys, now here we are on worksheet 11. I'm going to hit a couple problems on worksheet 11, a couple problems on worksheet 12, kind of fast forward to whatever questions you have, and remember we will have time at the beginning of class tomorrow to go over any questions you still have. We'll do a little bit of reviewing and then we'll take the multiple choice part of the test and do a couple of graphs on that section, I believe, and then do the rest of the test on Wednesday, okay? So first problem I want to look at for number 11 is this number 3 here, because you guys get a little freaked out, I can tell, by the domain and range when you're not given a graph. And so what I want you to think about is you have some sort of a picture of what this graph looks like, right? It's a sprinkler because it's a square root. This negative right here, I believe, flips it upside down. So instead of the sprinkler looking like this, it's going down like so. That's interesting. And so we also have a negative on the inside here, and that negative x actually flips it over the y-axis. So we have some sort of a sprinkler that starts at a point and then actually is upside down and to the left. So this is the shape of what this graph looks like. Now the problem is, how do we do domain and range? I know that like the 3 in here does something. I don't know about this 2. How do I figure out what the domain and the range are? Well, for the domain for sprinklers, you guys are always supposed to set the inside of the radical greater than or equal to 0. And the reason for that is that because you can only square root positive numbers. So greater than or equal to 0 means positive. So whatever's inside has to be positive. So we're going to do 3 is greater than or equal to 2x. I'm just going to solve this, divide by 2. And remember your inequalities. Doesn't this mean that x is less than or equal to 3 over 2? This means the same thing, but it's written in a different way. This is our domain. That means that this x value right here is 3 over 2. And it goes to the left forever. So I think that means that the domain is from negative infinity up to 3 over 2 bracket. And it's a bracket because you are allowed to square root 0. It doesn't have to be a parenthesis. You can take the square root of 0. The answer is 0. And then the range. The range is actually negative infinity to 0 because of this negative sign out here. Remember how our sprinkler is going down? And so it comes up to the point of 0, and that's because there's no plus or minus number out here moving the sprinkler up or down. Therefore, this is 0, and it goes down. Therefore, our range is negative infinity to 0. Again, it's a bracket on the 0 because you can square root 0 and get 0. Alright guys, next couple of questions I wanted to talk about was like number 15. So we've got like these weird looking expressions and f of x and g of x, and then we've got to do some domains, so these are a little bit more tricky. First of all, what I notice about f of x and about g of x is that they factor in the denominator, so this means that x over x minus 3, x plus 3, and this x minus 3 over x plus 3, x minus 1. I believe that's how that, factors in the denominator. Okay, so that is what these two functions are equivalent to. I'm just going to cross this out so I don't get confused because I factored it. So same thing, it's just factored. Alright, so forget about this. What this function says is that x cannot be equal to 3 or negative 3. And that's because both of those numbers would make the denominator equal to 0. You guys are used to that by now. I also have two numbers over here that I can't use, negative 3 and positive 1. Both of those would make the denominator equal to 0. X can't equal negative 3 or positive 1. Okay, so look, they both have in common the fact that you can't have -3. So if you think about these two rules of these equations, they both have one rule in common. This one has a different rule and this one has a different rule. So when I do f of x over g of x, that's taking my f equation, which is x over x minus 3, x plus 3, dividing it by the g equation, which is x minus 3 over x plus 3, x minus 1. And remember, when you divide fractions, that means that you keep the top and you flip and you multiply by the denominator. So we have x plus 3 coming up on the top and x minus 1 on the top and x minus 3 on the bottom. So we're flipping and we're multiplying. Okay, so you do notice that there is something here that cancels. The x plus 3's are gone. So this whole thing simplifies to x times x minus 1 over x minus 3, x minus 3. Okay, and so remember, when we do division, you know that there is something that comes into the denominator that means that we cannot have positive 3 in our denominator, because that would make both of these factors equal to 0. But we already said that up here. We already knew that x couldn't be equal to 3. So we have to incorporate this rule and this rule and this rule. And that is our domain for the f divided by g. There's nothing new when I do division, because both of those that would make the denominator equal to 0 is the number 3. So for the domain, I cannot have 1, 3, or -3. So that's from the original problem right up here. These two rules for the f equation and these two rules for the g equation. One of them is the same. They both say you can't have x equals -3. One of them says you also can't have x equals 3. The other one says you also can't have x equals 1. Check the denominator down here. We already said we couldn't have 3, so we already knew about that. To write that domain, we're going to go from -infinity to the first number I'm going to hit is -3. And then -3 up until the next number I'm going to hit is 1. The next number I'm going to hit is 3. And then I can go from 3 to infinity. So this is how to write the domain except 3 numbers, which is kind of long and annoying, but this says I can't use -3, can't use -1, can't use +3. So now if I do f times g, the f equation was x over x minus 3, x plus 3. And I'm multiplying by the g equation, which is x minus 3 over x plus 3, x minus 1. So multiplying these together, again, I can cancel these x minus 3's. Those are gone. So my final answer is just an x on top, and I have two different x plus 3's. I'll write it squared because I'm running out of room. And x minus 1 on the bottom. And remember that even though something canceled, that still has to be included in our domain. So we can't have 3, we can't have -3, we also can't have 1. This says I can't have -3, I already knew that. This says I can't have 1, I also already knew that. Okay, so the domain of f of g, or f times g of x, is the exact same as this. Alright, next one to talk about, you guys, is the step function here. This one with the -2 in front and the 1/3 inside with the x. So a couple of things to notice is that there is no plus or minus any number. There's no left or right movement. So I'm still starting my bar at 0, 0. And that's because there's no like +1 or -2 or anything like that. These are just stretching and shrinking problems. So know that this -2 on the outside multiplies your y's by -2. That means that I'm actually flipping all my steps upside down, so my stairs are going to be going in the down direction this time instead of up. That's what the negative does. And then the 2 here, that just makes my steps in between 2 units of space in between them. And then the 1/3 on the inside means multiply the x's by 3, which actually stretches your steps to 3 units long. And then the fact that I'm going down instead of going up when I'm making my pattern. So that's kind of like, you have to visualize what this thing's going to look like, and then always start your steps on 0, 0, unless it has been moved left or right or up or down in some direction. Let's see, I'm going 3 units long. So there's my open circle, and yes, the closed circle always starts on 0, 0 because this is rounding down. And then since I'm going -2, that's kind of like the slope in a way. I'm going down 2 and putting my next filled in circle, and then going like this. And I just need to continue the pattern all the way across the graph. So the next one is here, and the next one is here. So again, like they're 3 units long because of the 1/3 in here. There's 2 spaces in between each step because of the 2 here. They're going down because of the negative, where usually they go up this direction when it's positive. Okay, and the closed circle always starts on the left. Unless there was a negative on the inside here with the left, that is what would flip your bars the other direction, and in that case your open circle would go first. Alright you guys, now I'm moving to worksheet 12. I'm going to do a couple problems through here, and then whatever other questions you have on either of the worksheets, make sure that you ask those in class tomorrow before we take our test. Or you could email me or Schoology message me, and I'll do my best to explain to you anything that you might need explained. Where I want to start here is actually these 2 tiny little problems down here, number 6 and number 7. I know some of us are getting a little confused writing the equation of horizontal and vertical lines. And so what I'm going to do here is write the equation of the line through these 2 points. You know that the first thing that you're supposed to do is probably calculate the slope. And some of you might be recognizing already, which is awesome, that these have the same x value. Okay, but what if you didn't recognize that right away? If they have the same x value, you guys, then the answer is, whoa, that is not what I wanted there. Okay, if they have the same x value, then it's as simple as this, actually. The line is x equals -9. Okay, but what if you didn't recognize that right away? What if you wanted to do the slope and then go to point slope formula and blah, 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 blah? What if you wanted to do that? So let's start by doing the slope. -13 minus 11 goes on top over -9 minus -9. -9 minus -9. Okay, -13 minus 11 is -24, but -9 minus -9 is actually 0. This means undefined. So here's what you want to start thinking about. What kinds of lines have undefined slopes? Well, those are vertical lines. Vertical lines are x equals a number. And then hopefully by then you'll look up at your points and be like, oh, duh, the x values are the exact same. But some of you are trying to actually plug in the word undefined into the point slope formula, and that is not what we want to do here. This is an undefined slope. You need to think right away, okay, undefined means it's an x equals line, it's vertical, it's x equals the x value of both of those points up there. Very similar thing going on with number 7. Notice that the y values are the exact same, and pretty much what you could do right away is notice that and then be like, oh sweet, y equals -7. That's a horizontal line. You can also picture what those look like. So 5, -7 is somewhere down here, -2, -7. Oh, now I know what it looks like. That's y equals -7. Another way to think about that again is to do the slope. -7 minus -7 over -2 minus 5, 0 over -7. That means the slope is 0. And even then, if you do the point slope formula, y plus 7 equals 0 parentheses x minus 5. 0 times anything is just 0. So then you get y plus 7 equals 0, move over the 7, and we're done. Any way you think about it, you should get the same thing, but some of us are still getting confused at what do you do when it's undefined or what do you do if it's 0, so there hopefully clarifies some of those problems for you. Those are supposed to be really quick, but they're also very confusing. Alright, let's do this this weird looking graph for the domain and the range and all the other stuff. First of all, find the domain of this graph. I'm noticing that the farthest point to the left that I have is -7. So I'm starting at -7. And then I'm going to go up until, let's see, there's a gap between -2 and -1. So it's not continuous here. It stops at -2 and then starts again at -1. So I need to explain that in my domain. -2, closed circle, union, open circle on -1, and let's see, where does it continue? So -1 all the way until it stops here at 4. There's my domain, closed circle on 4, so bracket. Let's talk about the range. The lowest y value I have here is -7, so I'm starting there, -7, and let's see if it goes up until, let's see, the highest point here is -4, and then it starts again at -3. It doesn't continue there. I have this gap in between -3 and -4. So that means that I need to stop my range at this tallest point here, which is -4, and then start it again at -3. So -4 has a not open circle, so it's a bracket. And then I'm starting again at y equals -3. And then it goes all the way up until a y value of 6. It keeps going to the right here, but the highest point in terms of the y-axis is 6. So I'm stopping it at 6. Not an open circle on 6, so a bracket. Find the intervals where it is increasing. It's increasing right here, and it's increasing right here. So those are just the domains. Remember, that's just the x values. So the x values of this section are -7 up until -4. -7 to -4. Whoops, that should be a bracket. And the other section of my increasing part is -1 up until 2. Again, give me the x values. This x value is -1 and this x value is 2. And there's a closed circle here, but an open circle on -1. So I'm going to do a parenthesis on -1 and a bracket on the 2. Decreasing is this section and this section. No open circles at all, so all brackets. X value here is -4, x value here is -2, so that's my first section. -4 to -2. And then my next section is from the x value of 2 to the x value of 4. So this category here is also decreasing, 2 to 4. And then this one says find the x values where w of x equals -2. That means where y is -2. So I'm looking at along like the y line of -2, which is right here. I believe I touch my graph in two places, this place and this place, and it's asking for the x values. So the x value here is 0 and the other x value is 4. Okay, let me erase this so we can do the last part. Now it says find the value of w of -3. So w of -3 means when x equals -3. So when x equals -3, my y value here is -5. And I also have to do w of 2. So when I go to 2, the y value way up here is 6. And I have to subtract them, so that gives me -11. Alright, let's talk a little bit about the x-axis, y-axis, origin, symmetry, functions, that kind of thing. Let's see, for number 10, well, actually, let me talk about number 11 first. What I want you guys to think about for number 11 is, first of all, we're trying to determine symmetry. Second of all, then name the type of function if it is one. For number 11, you guys, don't make this harder than it has to be. You know what this graph looks like. This graph is a parabola, and I believe the vertex is to the right 5. Looks like this. Okay, so does this have any symmetry? You're asking yourself, is this line, the y-axis, a line of symmetry for the graph? The answer is no, because it's been moved to the right 5. Is this line a line of symmetry for the graph? No, it touches the bottom of it, but it for sure doesn't cut it in half. What if I turn my graph over 180 degrees? Then the parabola points down. That does not look the exact same as it does right now. This has no symmetry. Therefore, it's not even, not odd. It is a function, but it's not one of the special ones that we know because it doesn't have y-axis symmetry. It also doesn't have origin symmetry. Yes, it's a function because it's a parabola. No, it does not have any symmetry. If you wanted to do any of the tests in order to just see, if you're not into like using some common sense here on some of these graphs that we know what they look like, then if you make the y value negative, if I just shove a negative sign right here, that is not the same exact equation that I started with. What if I make this x value negative in here? Negative x minus 5 is different than positive x minus 5. That's not the same. What if I made them both negative? Then it would be negative y and negative x, but this negative 5 is still the same? No, it's not the same equation. So I get no for all three, which again means no, it doesn't have symmetry. But by the time some of your classmates have done all three of those tests, you guys could have done like 2 or 3 more problems on the test. So just kind of use some common sense when it comes to a graph that you know what it looks like. Okay, let's talk about number 12. This one's a little bit trickier. First of all, do you know what this graph looks like? This is a sideways V. Okay, is this a function? Not a function. Okay, but let's see if it has some sort of symmetry. So let's see if it has x-axis symmetry. That means when I plug in negative y for y, well, I'm pretty sure plugging a negative y into an absolute value means that that's the same exact thing as this, because absolute value is always positive. Yes, it has x-axis symmetry. That means it's not a function. Yes, it has x-axis symmetry. What if I tested for y-axis symmetry? What if I made the x negative? We'll pretty much know that's not the same equation that we started with. Not that. And then if I made x and y negative, the x would stay negative, the y would go back to positive, the 3 wouldn't have changed. Again, it's not the same thing. It does not have origin symmetry. This has x-axis symmetry. It is not a function, but we kind of already knew that because we pictured what the graph looks like. All right, I do want to talk a little bit more about some domains for this part 4. So first of all, what I want to do for this problem here is first find the domains of these functions up at the top, because then we're going to intersect them or combine them, kind of like the rules of the parents that we've been talking about. This is a parabola. The domain is negative infinity to infinity. Yeah, the 2 and the negative 7 and the negative 4 do some stuff to move it around and make it skinnier, but it's still a parabola. It still gets wider and wider forever. What I want to do for the square root is remember how we found the domain for any square root. You do the 3 minus 2x greater than or equal to 0 and you solve it. Negative 2x greater than or equal to negative 3. Don't forget to flip the sign when you divide by a negative. This means that my domain is going left. The sprinkler is going left because of the negative x on the inside. And that means that it's less than 3 over 2, which means negative infinity up until 3 over 2 with a bracket. Now let's talk about this last one, t of x. We're just still trying to figure out domains. For the domain of a fraction, you have to throw out whatever numbers make the denominator equal to 0. So I actually need to do that. This factors pretty easily. This means that I can't have positive 1/2 and negative 1/2. Those are the two numbers that if I plug in for x make the denominator equal to 0. So I'll just leave my domain kind of written like this so that I can answer the questions that I'm asked over here. So I know that you can do number 14 and number 16. All that means is plug in negative 3 to the t, also plug in negative 3 to the w, and add those numbers together, you guys. This one for negative 5, plug in negative 5 to the c, anywhere there's an x. Also plug in negative 5 to the t and multiply them. You guys know how to do that, but let's talk about the domain. So the domain of t and w. So what I have to do there is take my rules for the t function, which mean I can't use positive 1/2 and I can't use negative 1/2. And I also have to take the rules of the w equation, which means I can only use numbers less than or equal to negative 3 over 2. And I have to combine this set of rules and this set of rules. So think about like the number line. We can go to the left forever, and we have to stop at 3 over 2, and we have to skip negative 1/2 and positive 1/2 along the way. That is the combination of all the rules of t and w. So there's a lot of rules for these parents. When you live under their roof, you have to obey all of them. So going up to 3 over 2, that's 1.5, right? So that happens after 1/2 and negative 1/2. So I have to skip both of these numbers and go from negative infinity to 3 over 2. So the domain is negative infinity to, what's the first number I'm going to get to? Negative 1/2. And I can't use negative 1/2, so it has to be a parenthesis. Then I go from negative 1/2 until, what's the next number that I'm going to hit? Positive 1/2. I also can't use that one. It's a parenthesis, so I can't use it. And then I'm also going to go from 1/2 up until my stopping point for this equation says stop at 3 over 2. So stopping there, that one is a bracket. You're allowed to use 3 over 2, but you can't use anything past it. This is the domain of t plus w. Now let's do the domain of c and t. So remember that c had no rules. That was negative infinity to infinity. So when I combine this rule, which is no rules, with this, that means that these are the only two rules I have to obey. So negative infinity to negative 1/2. Can't use negative 1/2 because it's in the denominator. Negative 1/2 to positive 1/2. And 1/2 to infinity. So it's just the rules of the c equation, which is no rules, it's negative infinity to infinity, and the rules of these two, which say you can't use 1/2, you can't use negative 1/2. So this is how you write the domain of all that. Okay, last one from this section I wanted to look at was number 20 way down here. I'm going to do the writing up here so that you can see it okay while I refer to the equations up here. I'm going to use the C and the W. And so this is the symbol that we learned. It means composition. You're plugging a function inside another function and evaluating it, in this case at -2. So this means C of W of -2. So what I'm doing first is plugging in -2 to the W. So I'm going up here to my equation for W and I'm plugging in -2. So when I do that, W of -2 equals square root of 3 minus 2 times -2, which is square root of 3 plus 4, which is 7. So now what I'm doing is C of radical 7. That means I'm taking radical 7 and I'm plugging it in up here wherever there is an x. And so what that means is it's going to look like this: 2 times radical 7 squared minus 7 times radical 7 minus 4. And then just simplify whatever you can. And that means that the square root of 7 squares away, so I get 7 times 2 is 14, minus 7 radical 7 minus 4. So I can combine the 14 and the 4 and get 10, and get 7 radical 7. Okay, so that is the answer to this one. Sorry, I wrote kind of big there. But that's how you do that one. That's what that little O symbol means. And sometimes it's just an X that they give you. In that case, you don't have to plug in any numbers. You're just taking the entire equation and plugging it into the other one. Okay, guys, last one I want to talk about here is number 19. Finding the domain of W over C of X. So that means that I'm taking my W equation, which is the radical 3 minus 2x, and I'm putting it over the C equation, which is 2x squared minus 7x minus 4. And so first of all, what I want to do for that is notice that I think the denominator is going to factor down here. So I want to do that. This is going to factor into 2x and x, -4 plus 1. Get that factored right? Yeah. So once I get it factored, the fact that this is in the denominator means that x cannot be equal to -1/2. This says that x cannot be equal to 4. Okay, so let's talk about the domain of these two equations. So let's go back to the original part that we did the domains at the very beginning. And for the C equation, there were no rules. But for the W equation, we knew we could only use numbers that were less than 3 over 2, less than or equal to. And so now we have two new rules down here. We can't use -1/2 and we also can't use 4. So we have to stay within these rules. We can't go past 3 over 2, but we have to skip -1/2 and +4. So that's what I'm going to kind of go with. I know that I can't go past 3 over 2, but I also can't use the numbers -1/2 and 4. So here's where it's a little bit tricky, is that I know that I can't go this part. I'm going to write it so I don't forget it. -infinity to 3 over 2. We did that at the beginning. And this one says I can't use -1/2 and I can't use 4. Well, I'm pretty sure that 4 does not fall into this category anyway. This one tells us that we cannot go past 3 over 2. And 4 is not in that set of rules, so we don't have to worry about that because we're restricting our domain already to this part. So the only number that I have to exclude for this is -1/2. So when I write my domain, I'm going from -infinity to -1/2 and -1/2 to 3 over 2 with a bracket. Okay, and why didn't I use the 4? Because this one told me I had to stop at 3 over 2. 4 is outside of that domain. So I can't use it anyways. I'm stopping at 3 over 2, so therefore 4 is not in that category. So I already took care of the fact that I couldn't use it equal to 4. So I'm going from -infinity to -1/2 because -1/2 would make the denominator equal to 0, and then from -1/2 to 3 over 2 because this function tells me I have to stop at 3 over 2. 4 is outside that boundary anyway, so you do not have to add that back into your domain.